Today we're gonna switch gears up a little from all the fascinating knowledge graph stuff I've been talking about in the last couple of videos. And we're gonna talk about another very important topic in the world of building advanced and production grade RAG and language model applications. And that topic is evaluation. At this point, most people understand that it's really quite simple to get started building a simple RAG application from your data. You can set up that vector index from your documents and set up the retrieval and the language model chat interaction. And even if you have a lot of documents, you can really set all of this up, especially if you're using a library like LangChain or LlamaIndex. You can really set all of this up in less than an hour. But what's also becoming increasingly clear is that these basic implementations really in almost all cases aren't reliable or accurate enough for any kind of real-life use. And this was demonstrated really nicely by one presentation at OpenAI's Dev Day at the start of November, where their team shared a story of them building this kind of a RAG system for one of their clients. And they started with this basic system that had about 45% accuracy in the responses given. And then over several months of experimenting with dozens of different optimization methods and even becoming a little skeptical at points along the way, whether or not it's possible to take this to production, then ultimately they did achieve a system that had a 98% accuracy. And so those kinds of levels, they are achievable, and there are a lot of methods out there for optimizing these systems. But the key piece that you need to have in place in order to apply these methods properly is an evaluation framework. And what an evaluation framework is going to allow you to do is collect real quantifiable metrics from the performance of your system, set a benchmark for baseline performance, and then that's going to allow you to systematically try different methods, try different configurations, run the evaluations again, and then you can start to see and compare which optimization methods actually move the needle and improve the performance in the way you want. Because the reality is that the bottlenecks are always in different places for every project, depending on the type of data that you're working with or the types of specific outputs that you want the system to give. There's no one-size-fits-all solution where you just apply these methods in sequence and then you get your production application, but rather it really requires this systematic, almost scientific approach of experiments, trying different methods, seeing what works, seeing what doesn't work, and gradually increasing the performance all the way to those production grade levels. Because if you don't have this kind of evaluation framework in place, then you're just stuck making rough guesstimates and eyeballing based on a small sample size of responses, trying to get a sense for how the responses are, trying to adjust one thing and the other thing. But this kind of a non-systematic approach is really not going to cut it for getting to those really high-performing production systems. And so that's my little rant on the importance of evaluation frameworks. And so in this video, we're going to walk step by step into how you can start using one such framework called TruLens. And that's going to allow you to collect a lot of different metrics for your RAG system. And TruLens also gives us some great tools for visualizing the results of these metrics that we collect. And this is going to allow us to very easily set up a leaderboard and allowing us to compare the performance of different versions of our application, different configurations. And this is going to be very helpful as well. Okay, so we're here in our notebook in VS Code, starting with some standard imports, loading our OpenAI API key. And then we're gonna download our source document, which is a chapter of one of the IPCC reports. And although it's just one chapter, it's still 170 something pages, 60 pages or so of scientific references. So we are gonna trim that down even more, and we're gonna take a subset of that PDF into a smaller PDF, just taking the first 30 pages. And that's what this helper function is for. And I've already done this here, so I have the subset here in a separate 30-page document. And so with that, we can get started on the RAG setup itself. And we're going to be using LlamaIndex for a lot of this setup. So we're going to import and initialize some of those wrappers from the library, our assistant model wrapper, and then a different one for the embedding model. And then we're going to initialize those. And with the embedding, we're just going to use the defaults. We're just going to use the ADA2 model. I've actually been enjoying LlamaIndex increasingly as a library. They do have a bit of more of a focus on RAG specifically and like data applications compared to LangChain, which is sort of more trying to be a catch-all library for LLM applications. And maybe that partially is the reason why their abstractions, the way the library has been built so far, is a little just harder to understand, I find personally, and I'm not the only one. But with LlamaIndex, I find with this focus, their documentation is a bit more clear. And yeah, I like the library a lot. Whereas I'm more and more moving away from LangChain, I must say, I try and use it as little as possible. Although I still use it for some things, I try and use it less and less these days. So now we can load our data from the document, split it into chunks. Also using some utilities from LlamaIndex for that. So it's going to take a file path. And then the load data method is gonna load the text from the PDF and create a list of chunks or document objects from the text. And I think by default, it's gonna chunk each page into its separate chunk. So we should have 30 chunks in this list, but I might be wrong about that. Great, yeah, that is the case. We have 30 of these documents. And each document is going to contain the document ID, and then it's going to contain the text for that page. So next we're going to write some functions to build our indices, and I say plural because we're going to actually build 2 different indices with slightly different configurations. And then this way we can run the TruLens evaluation on each of these indices and see which one is performing better. So that's the goal here. We're going to import some more classes here that are going to help with that. And we're going to start with a basic index that's just going to use the default configurations, basically, taking the language model wrappers that we have initialized here. And this service context object is basically just a bundle of components you will typically need when building an index. So we're just going to use the defaults and then the index itself, using the documents, and then the service context argument that we pass to this vector store index is going to be our basic context. And then we're going to just return that basic index that we have created. Great. So we'll start with that, and now we can actually configure the evaluation framework. First, we're going to just import from TruLens _eval. We're going to import the true class. This is just the main entry point to the library. So we're going to create an instance of that, and that's going to carry us through the entire thing. Next, a lot of these metrics, and I'm going to talk about this a lot more in a minute, but a lot of these metrics basically use a language model in the evaluation to get different values and different metrics for the results. So when we import the OpenAI class from TruLens, that's basically going to help the framework get those metrics using the language models from OpenAI. So we're also going to initialize that. It's called a provider. It's a metric provider. You can use various different models. In this case, we just use OpenAI. And then another essential thing you need for these kinds of evaluations is you need a test set. So you need some set of questions that you can then run against the system and see how well it answers those. And optionally, you also want to have the actual correct answers for each question. You can get some metrics without even having the ground truth answer for the questions, but ideally you want to have both. So we have those here. We have 10 questions and question answer pairs in this CSV, with each question being answered somewhere in this chapter, in this document. So we're going to read those into a data frame, first of all. And then we're going to parse that data frame into basically a JSON object, because TruLens expects the test set to be in a certain form, and this is the form where the query key holds the question, and then the response is where the answer is. Then it's going to look like this dictionary pair of keys and values. And then we can actually move on to defining the metrics that we want to collect. And this is probably going to be the most dense and in some sense complex part of the whole video, but bear with me. It's going to make sense at the end, I think. Our first metric is going to be answer relevance. And it's basically in the name, but this metric is going to give us a value for how relevant the given answer by our system is to the question of the user. The way we define that is by importing another class from TruLens, which is the feedback class. And then the feedback is going to take a few arguments. Mainly it's going to refer to the provider, which is our OpenAI provider. And then we're going to define the feedback function or the metric function that we want to use for this one. And there's a lot of these available here. But for this one, we are going for relevance with chain of thought reasoning. And then we're going to give it a name, answer relevance, which is just a name we're going to see then eventually when we visualize these results. This is going to be the name that we see this metric under. And then finally, this relevance function method is going to take two arguments. It's going to take the input to the system, which is the question, and then it's going to take the output, which is the answer. And then those two other things it's going to compare to see how relevant the answer is to the given question. And there are different ways we can pass those arguments to the relevance function. But one simple way is to just add this onInputs output method here at the end, which is just going to do that exact thing. It's going to pass the question and answer to this feedback. And next up, our next metric is going to be context relevance. And this is going to be quite similar to the first one, only that instead of measuring how relevant the answer is to the question, we're going to measure the relevance of the retrieved context, which means in the context of RAG, we are going to, as part of our answer generation, we're going to first retrieve some chunks, some pieces of our, in this case, IPCC document that the LLM can then use to generate the answer. We are basically taking a step back from the answer relevance and just measuring the relevance of the context. So that's all that this measure is. And we are using the same function, which is relevance with chain of thought reasons. The only difference is that instead of comparing, again, the relevance of the question to the answer, we are defining it slightly differently here, where, yes, the first argument is going to be the question, just like before, but then the second argument is going to be the retrieved chunks or the retrieved nodes in the case of LlamaIndex. Nodes basically being the basic unit of indexing and retrieval. When you're using LlamaIndex, that's the name that is used there. So for that purpose, when you're using TruLens with a system that's built on LlamaIndex like ours here, they have a class to make that easier that we also import from TruLens. And among other things, that's going to allow us to refer in these feedback arguments to the retrieved context, or like I said, retrieved nodes. And we're just going to get the text from those nodes because they also have some metadata in them. But we're just going to look at text content of the nodes, and then we're going to compare the relevance of that text content to the input. And then finally, because unlike in the first example where we just have one question and one answer, so we can just run the relevance metric once, here we'll probably, as usually is the case, we'll have several pieces of context, several chunks, several nodes for a given question. So we're going to need to get the aggregation of all of those. So we're just going to get the average. We're going to run the relevance for each piece of context and then get the average. And we're going to do that by using the NumPy library that works with TruLens. And that's our context relevance defined. Again, like I said, this is quite a lot of stuff, especially if this is your first time ever looking into one of these frameworks. But you'll see that whether you use TruLens or Ragas or any of the other several frameworks that are now popping up there in this space for this purpose, these metrics are actually going to be more or less very similar across all the frameworks. You'll see things like answer relevance, context relevance, answer correctness, independent, no matter what framework you use. So trust me, once you just wrap your head around it once, then in the future it's going to become a lot easier. And like I said in the beginning, this is a very essential topic if you want to build any kinds of serious LLM or RAG applications. So let's move on. We have two more metrics that we're going to define here. And I would say these are maybe the most important ones that we're going to show next. This one being groundedness, sometimes called faithfulness. And this one we actually need to import separately. And basically what this metric is going to do is it's going to look at the answer generated by the system, and then it's going to look at the source document, and it's going to see how well the claims made in the LLM's answer can be traced back to something real in the source information. So if the LLM makes some claim in the answer, can that claim actually be traced back to something that's clearly said in the source documents? or is it hallucinating? So in other words, groundedness or faithfulness, it's simply a measure for hallucination. How much, when you have a higher, better score of groundedness, then you have less hallucinations. If it's a lower score, then there's a chance that the language model is making stuff up that's actually not backed by the context. So this is a very useful, important metric. And the arguments that this groundedness function is going to take are going to look familiar here. This time the retrieved context, the retrieved nodes, is going to be the first argument that we pass. And then the second argument is going to be the output, which is the answer. So these two are what we need. We're going to look at the answer, and then we're going to look at the source information, and we're going to see how well they align. And again, because we have multiple source nodes that we are looking at, we need to aggregate this. And this is going to look a little different here, because without going into too many details, the way the groundedness metric works under the hood, it's also going to separate the system generated answer into a collection of statements and then see for each of those statements how well they are backed up by the source information. So basically for that reason there's a specific type of aggregator to make it work, to get the average across all the statements and all the nodes. Now you do have all this information available on the TruLens.org, TruLens eval website, the documentation. I would say it's very good. So if there's something that isn't quite clear to you fully after watching this video, I highly recommend you play around with yourself, of course. I'll make the code available. The repo will be available as always with the code, and then you can also look at this documentation for any details about how the functions actually work behind the scenes. But for now, I'll leave it at that level of detail, and you can then look into it yourself more. And then finally, we have one more metric left to define, and this is going to be the agreement with the ground truth, which is just finally, again, a very important metric. How correct are the answers actually? Now, until now, we've been looking at things like relevance and amount of hallucination, but because in our test set, we have not only the questions, but we also know what the correct answer should be. We can then also look how close are the system generated answers, the LLM generated answers to those correct answers. And so that's what this last metric, ground truth agreement, sometimes called answer correctness, that's what this is all about. And we'll also need to import this separately. And this function here is gonna take an argument. And for this, we are first of all gonna pass the benchmark Q&A set, our dictionary of keys and values or queries and responses, and then this function is going to compare those to the inputs and outputs of our system. And so that's our 4 metrics defined, and now we're actually very close to being able to run our first round of evaluations. We're just going to put these feedback instances into a list. So Q&A relevance, context relevance, groundedness, and then ground truth. For the next step, we're just going to be defining a helper function to get us a TruLens recorder, and this is basically going to be something that's going to take care of running and recording the results from the evaluation. And it's going to need a query engine, which is a LlamaIndex concept I'm going to explain in a second, and then just an app ID, which is an identifier for this app, which is going to be used when we have several different apps or app versions in our history of evaluations. Then this ID is going to allow us to identify all of those different versions in the history. So the recorder is going to be using the TruLlama class, which again is this class that TruLens uses to interact with applications that are built on LlamaIndex, like our example here. Now there are other ways, if your application is built using LangChain or even directly using OpenAI's API, there are ways to set up TruLens for those kinds of applications as well. I'm going to talk about that later, but for now we are using this LlamaIndex example, so it's going to look like this. So TruLlama, again, this is where we're going to pass the query engine. Feedbacks is going to be the list of feedback instances that we define and include in this list. And then finally the app ID is going to be the app ID. And then we return this recorder object for further use. And now the last thing left to do is actually build the index. So our basic query index is going to be built using this first function we defined. This one, which is just going to create a basic index from our documents using the default configurations from LlamaIndex, default chunking and all that. Again, using these documents that we load from the IPCC chapter. We're going to build that index, documents, and then the language model wrappers we defined also in the beginning. And then we're gonna initialize the query engine. And so, like I said, this is a concept in LlamaIndex. And so basically, once you have defined an index, then the query engine is basically an interface that you can build on top of that index or several different indexes that allows you to then ask questions, have an interaction with that data. So yeah, index being the thing that contains your data, and then query engine is an interface on top of that. That's the basic idea. And as a side note, another reason why I like LlamaIndex is that not only do I like the library and the utilities and the modules that the library has, but actually their website is also, and their documentation is also a really good source of this conceptual understanding. They have a lot of information about RAG more generally, different strategies for optimization, retrieval strategies, even some stuff about agents and evaluation, fine-tuning. So it's really a great resource, again, not only for helping you build solutions faster by using the modules, but also just by learning about the topic of RAG more generally. So that's a bit of a side tangent. There's no partnership between me and LlamaIndex, but hey, when you find something that's useful, then I'm happy to talk about it. So back to our evaluation setup here. Once we have the index defined, then there's a method to create that query engine, that interface on top of that index. So it's as simple as this. And then finally, the recorder, basic recorder, we're just gonna get with this helper function, get TruLens recorder, passing the query engine there, and an app ID. And we're just gonna call this basic query engine. And now all that's left to do is actually run the evaluation itself. So with the basic recorder as recording for each question in our Q&A sets, we're gonna run that query using our query engine, and the query is going to be for each question. It's going to be the query. Again, this is the way we access questions in our Q&A dictionary. And as we do, this recorder is going to store the results and store the metrics for each of these questions. So that's all we need. We're going to run this. It might take a while, so I'm going to fast forward here. And now that that's been run in about 1 minute, now the results have been stored by default into SQLite library here in the working directory. You can also define some external database if you want to, but we can now access these records and feedback from the TruGet records and feedback function, and you can define which apps you want the records from, or in this case any or all, and we can just see the top 5. Actually head like so. And now the thing I like maybe the most of all about TruLens compared to alternatives like Ragas is that, like I said in the beginning, they do have a very nice way to visualize the results you get from your evaluations. And they do that in the form of a dashboard. So they've built, as part of the framework, a dashboard using Streamlit that you can simply run, and then all the results, all the records that you store by running these evaluation pipelines, they're going to get displayed here. So this is the app ID that we just gave to our first version, and then we can see here not only the 4 metrics that we defined, so answer relevance, context relevance, groundedness, answer correctness, or ground truth, but also we can see some additional information like token consumption, which is then of course gonna affect the cost, but also latency of your system, how long it takes to generate the responses. And of course the token consumption also is a function of your configuration. Like if you use larger chunks, then the system is gonna consume more tokens. So this is also something you're ideally gonna want to try and drive down, so it's useful to know. So I think this is very cool. And then here, if we go to select app, then we're going to see even more details about the evaluation. We're going to see the question by question details. So we can then also see which specific questions the system is performing well or not so well in. And this is also going to help us think about what steps we're going to take to try and improve the results. So that's the basic idea of how you can use TruLens. But now we're going to move on to what I think is the coolest part about all of this, which is that now we're going to set up a different kind of index using the same data, the same document, but the way we do the chunking and the retrieval, we're going to use a slightly more advanced configuration. We're going to use a different method for doing that. And then after that, we can run the same evaluations again and see how these metrics improve for this different version of the application. So let's get into that. This is going to be something called a sentence window index as opposed to our first basic index. And you're going to understand what that means in just a second. And we're going to define a new function for this next to our basic index building function. And we're going to need to import a different kind of a node parser from LlamaIndex for that, called the sentence window node parser. And I'm going to define this function first, and then I'm going to explain in a bit more detail about how it actually works. But same thing, it's going to take as arguments the documents, the LLM, and the embed model. These are going to be the same. But what's different is that we're adding this more advanced node parser into the service context. And then for the service context, it's going to look a little different, because not only are we going to define the service context from defaults like before, passing in the LLM and the embed model, but this time we're also going to use define something for this node parser, which is going to be our sentence window node parser here. And then finally, with the context defined using the node parser, we can then create the index, vector store index from documents. Okay, so what does this sentence window indexing actually mean, or what does it do? Well, there's a whole article about it in the LlamaIndex documentation. But the basic idea is that when we use this sentence window node parser, each individual sentence in the source document becomes one node or one chunk. So it's a very fine-grained way to do chunking. Instead of going for entire paragraphs or even pages of the document, we get the chunking at the level of sentences. At the same time, although it's very fine-grained, each of these single sentence nodes also has a window, or it contains the information about the sentences that came before that, and also the sentences that came after that, one sentence. So we still maintain this surrounding context while getting the benefits of having this fine-grained chunking. So that's just a very, very brief summary. You can read more about it in this page, but it's also summarized nicely here. This can be a useful method to do when you're dealing with large documents and you want to make the retrieval more fine-grained, more specific. So that's all that is, and that's our function. So we're just going to save it, and then we are going to define our sentence window index here with that function. So documents, and the models are the same as they were before. Now, compared to the basic index and the basic query engine here, there's another slight difference, which is that we're also going to define a post-processing function into the retrieval and into the query engine. This is going to handle the windows of sentences surrounding each node. That's basically what this is going to do. And for this, we're going to import a class from LlamaIndex indices post processor imports metadata replacement post processor. And this is going to target, there's a lot to go into on this class as well, but it's basically going to target, in this case, the metadata with the key window, which is the key for our sentence windowing metadata here. So we're going to define that as our post processor, and then with that we can define the query engine, sentence query engine, and this is going to happen the same way as before, as query engine, only with the difference that we are also going to define the node post processor as this post proc here. Now you can have several different post processors as well. This is why this is a list. So you can do all kinds of stuff after the retrieval. After you retrieve the nodes, you can then apply various post processing functions with LlamaIndex. So that's a whole interesting topic on its own. For now, we're just going to go with this. And then finally, now we have our query engine, so we can define our sentence recorder or sentence window recorder, which is then gonna handle our evaluation, running the evaluation, recording the evaluation, just like before. We get TruLens recorder, we pass the query engine, and then we give this app another ID. We'll just call this sentence window query engine. We're gonna run this. And now that that's done, we are again going to run our evals with sentence recorder as recording for queue in Q&A sets. Okay, so now that that has run, we can go back to our leaderboard, which should still be running, and then we should be able to see these results from the second run. So here's our previous basic query and then the sentence window. And we can actually see here that our metrics haven't gotten all that much better. Actually, they've gotten a bit worse, especially when it comes to answer correctness. Really, the only thing that has improved here is the token consumption, which is unsurprising because we are using smaller nodes, but otherwise it doesn't really look very good. But that's how it is sometimes when doing this kind of stuff. You try something and maybe it doesn't work, and then you try something else. But what's also useful in that whole process is to make it somehow visual, whether that's just to your team, but also probably to your clients, to who you're building something like this, that they can also follow the progress you're doing, the different experiments you're doing. So that's why I really like this kind of a leaderboard, dashboard type of thinking. And of course, you can use the data from TruLens, but also any other framework to build your own custom dashboards. If you want to host it somewhere else than Streamlit, that's perfectly valid. But at the very least, I think this can give you some good ideas for how that kind of a monitoring evaluation dashboard might look like. Now there's one last thing I want to talk about, and I alluded to this earlier, which is running these same evals for your custom RAG application. Like I said, in this example, we are using LlamaIndex for all of this, the indexes, the query engines, and that's all well and good. But if that's not your situation, then TruLens does also have support for LangChain based applications with this class here, TruChain. But even more importantly, if you are doing something entirely custom, maybe you're calling the OpenAI API directly, or otherwise you're using custom functions or custom classes to do your RAG, your retrieval, then they do also support that with this True Custom App class, where you can, regardless of how your function is defined, you can, with a few extra steps, wrap those around this class, run the exact same evaluations, get the same dashboard, get the same data as we did here in our LlamaIndex based example. So I wanted to include that part also in this video, but I feel like it's already getting quite long, so I'm gonna save that for the future. So if you'd like to see a video like that, specifically about how to use TruLens for your custom application, let me know in the comments or otherwise, and I'll happily get down to that. But for now, I'm gonna finish it here for this video. In any case, there are definitely gonna be more videos coming on evaluation because it is such an important and interesting topic in this whole field of RAG. So stay tuned for those. And as always, I hope you found this useful, and I'll see you on the next one.